one more time. So it should be 18 students. Let's go share my screen. Broadcast. Video. Let me, yeah, I got it here. Oh, where'd it go? 2 p.m. Okay. Yeah, that's correct. Marcus down is absent. Okay, so I'll check attendance again a little bit later on. I usually do it at the 15-minute mark. All right, scholars. So welcome. I'm just trying to think of announcements. I'm still kind of making my way through grades. It's just taking me much longer than I anticipated. Midterm grades. The midterm grade is just based on, it's just a snapshot of where you are at this moment in time. So once I get it loaded, it'll be based on everything from the beginning through exam 2. And that's pretty much chapter 1, including exam 1 and exam 2. So the homework, quizzes, and exams, but all of it is centered around chapter 1. And so today, let's see. It's already a sequence. No, I didn't want that. Okay, that's good. Okay. So today, we're going to start chapter 2 on polynomials and rational functions, and we're going to start off with section 2.1, quadratic functions. As usual, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. And try to, resolve the matter. Yeah. Okay, a few objectives here. 1, graph a quadratic function in standard form. 2, graph any quadratic function. 3, solve problems modeled by quadratic function. Sorry. Okay. So a quadratic function, a function of this form, f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, where a is not equal to 0, is called a quadratic function. All right, so we've kind of explored this a little bit with our library of basic functions. This is similar to like the squaring function, where it's a U-shaped curve. And so we're going to look specifically at the squaring function, more namely the quadratic function, some of the properties and techniques that come out with this function. So the standard form of a quadratic function. The quadratic function given here, f of x equals a times the quantity x minus h squared plus k, as long as a is not equal to 0, is in standard form. The graph of f is a parabola with the vertex h comma k. The parabola is symmetric with respect to the line x equals h, called the axis of the parabola. If a is positive, the parabola opens up, and if a is negative, the parabola opens downward, right? So this is the standard form of a quadratic. I think the other form was, I guess you can call it the general form. I think there's another form for the general form, but you can call that the general form. When a quadratic is in standard form, I feel like that's the easiest way to graph a quadratic. It's similar to like with lines. When we have a line in slope-intercept form, it gives us a lot of information about the line, and it's easier to graph in that form. Quadratics kind of have a similar mechanism. So when it's in a standard form, the h comma k are going to be the coordinates of the vertex, right? If the parabola opens upward, then our parabola is going to have a minimum value. If the parabola opens downward, then our function is going to have a maximum value. And then the leading coefficient a, if a is positive, then the parabola opens upward and we're going to have a minimum. If a is negative, the parabola opens downward and we're going to have a maximum. And then we can use the axis of symmetry of the parabola to get a better graph, right? So once you identify the vertex, the axis of symmetry is going to be the x coordinate of the vertex. So it's going to be a vertical dashed line going through that point, the vertex of the parabola. And then once you identify the axis of symmetry, whenever you get a point on the graph on one side of the axis, you automatically get a point on the other, right? So you can use that to create your graph of the quadratic. Okay. So here we're asked to find the standard form of a quadratic function whose graph has this vertex and passes through this point. So hopefully you have a formula sheet. If you have a formula sheet, it is a good idea to update your formula sheet with the quadratic function in standard form. And again, that is going to be as follows. I'll put it here. x equals a times x minus h squared plus k. Okay. Where the h, k are the coordinates of a vertex. So this is our h, this is our k. You got to be careful with the signs here. It's easy to do your signs improperly and mix it up. If it's passing through this point is going to serve as our x and our y. Okay. So let's plug in what we're given and see what it's looking like. Now, I don't think we have any information on a. We said the x here. Let me see. We have x minus h squared plus k. So what I did is I replaced each unknown with a blank set of parentheses, and I'm going to do my substitution. Remember, the blank parentheses help us to keep track of our signs, so we're less likely to make mistakes with our signs. So then our x is going to be -4. Our h is -3. Our k is 4. And this all equals our y value, which is 7. Okay, so I just plugged in everything that we were given. Notice at this point, we have one equation, one unknown, so we can solve. Okay, so then notice here, we got a double negative becomes positive. So this minus a -3 is the same as adding a +3. -4 plus 3 is going to be -1. -1 squared is going to be 1. So then all of that collapses to just a. Plus 4 equals 7. So then a equals 3. Okay. So then our function in standard form should be 3 times x minus our h. So minus a -3, we're going to write that as x plus 3 squared plus 4. Okay. Yeah, I'm starting to realize, like, I was like, why am I sleepy today? I was like, I mean, I took a nap, but it's like whenever I have to do things before I meet with you all, it like, I don't know. It's just hard for me to like get my energy. I usually like go into a deep, deep sleep. And so I can have energy for this next like 3 hours, I guess. Okay, so I think this looks good. Let's keep going. So find the standard form of a quadratic, yada, yada, yada. It plugged in different components. When x is -4, y is 7, so a is 3. I think we got the same thing. Here we're asked to sketch the graph of this. Okay, so notice that this quadratic is already in standard form. Okay, so let's kind of list out the information that this gives us. In this form, we can quickly see that our h, k, the coordinates of our vertex. So remember, that's x minus h. So our h is actually going to be -2. And our k is going to be 12. Okay. So that means the equation of our axis of symmetry is going to be x equals -2. And so we can use the axis of symmetry to generate points on either side of the axis. And then also notice that our a is -3, which is negative, right? So that means that our parabola opens downward. So our vertex is at the coordinates -2, 12. That puts us in quadrant 2. And our parabola opens downward. So we're kind of focused on quadrant 2, right? So I'm just going to do a rough sketch. Matter of fact, I think I will introduce graph paper this time. So the text box. Paper. What's the time? Okay, let me see my clock. I give them like 30 more seconds. Okay, we're focused on quadrant 2. So I'll put my origin like in this region. We're gonna so this way our graph can kind of focus on quadrant 2. We'll let this be our positive x in this direction. We'll let this be our positive y in this direction. Okay. this is our positive x over here, positive y in this direction. Let's see. So negative 2, 12. Okay. So let me think. I'll let this be my negative 1. This will be my negative 2. Okay, here's my origin. And then 12. Let me see. 2, 4, 6, 8, 10, 12. Okay. This went by 2, 4, 6, 8, 10, 12, 14, 16. And this one went 1, 2, 3, and these are negatives. So 1 there, 2, 4, negative 2, negative 4. Okay, I think that's good. Let's shrink this down just a little bit. Okay. We'll do it in blue. You said what, negative 2, 12? Let me do one other thing. Paper. I like, come on. There it is. Yeah. Okay. So negative 2, 12, it puts us right about there. A little bit off, but yeah, negative 2, 12. Okay, so that's our vertex. Then we have our axis of symmetry. That's right, come on. There it is. Like, man, it is like giving me such a hard time today. Like that. It's not working either. Let's go paper. Let's turn it off right now. Okay. So then our axis of symmetry. And let me go style. About like this. About like that. That's decent. Okay. Let me label some of these components. So this is negative 2, 12. It's the ordered pair. This is the axis of symmetry, x equals negative 2. And then we just need to plot a few points. So let me see. When x is 0, all right, let's see what happens. When x is 0, that's going to be a 2 squared is 4. 4 times negative 3 is negative 12. So when x is 0, y is 0. Paste. So we have, it passes through the origin. So then when we go 2 to the right, y is 0, then when we go 2 to the left, y should also be 0. Okay. So paper, let's bring this back. Let's see. So that's negative 3. That's going to be negative 4 right there. So that means when we go 2 to the left, we should also be at 0. That means right here. Let's see what happens when x is negative 1. When x is negative 1, negative 1 plus 2 is 1, squared is 1, times negative 3 is negative 3, plus 12 is 9. So when x is -1, the corresponding y is 9. That's like right there. So then that means when we go to the right by 1, the corresponding y value is 9. So that means when we go to the left by 1, we should also be at 9. Okay. Then to bring it all together, we're just going to connect these dots with a smooth curve. And so basically what we did, we found our vertex, we found our x and y intercepts, we found our axis of symmetry, and then we use the axis of symmetry to find a few additional points, right? And then we're just going to connect all these points with a smooth curve. Let me see something. I don't think it's on this graph. Nothing wrong with it. Try one more time. Yeah, I don't know. On the right-hand side, I think it's a little bit, right? Okay. And let's go paper. I'm going to check Zoom. All right. So when we did it by hand, these are all the components to combine. Okay. So they got the -3 leading coefficient, the same vertex. Okay. They found the x and y intercepts. We just kind of stumbled across them, but we got the same graph. Okay. Let me check you guys Zoom. Get the students. That was 227. Let me see what we have. And then if I check chat. Okay. All right. Do we have two? I think we do. Let me make sure I got the right one. Yeah, okay. All right. So, okay. So back to where we left off. Come on. This thing. All right. So we're actually sketch the graph of this. Now, so notice that this quadratic function is not given to us in standard form. So with this being College Algebra 1, we do expect for you all to, to have some level of proficiency when it comes to factoring, right? So there's a couple of ways that we can go about this. One technique is to change this into standard form, right? And so we would use the technique of completing the square, to change this into the standard form. Now, if I say the phrase completing the square and you don't automatically know what to do, I would encourage you to do a YouTube search and find a few videos, watch a few video tutorials on how to do completing the square. I'll do a demo here, but it's a good idea to just and this is just one way to go about it. We have another technique as well, aside from completing the square. Okay. So let me start by getting a copy of the original. We have this f of x equals 2x squared plus 8x minus 10, okay? So one of the first things when it comes to completing the square is that the leading coefficient has to be a 1. Notice our leading coefficient is a 2, right? So I'm going to factor out 2. I'm just trying to think of how I want to do it. I'm going to factor out 2 from I guess I'll just do all of them. It's fine. All right, I'm going to factor out a 2. So now if I do this, we get the following. Let me give myself some space. So if we factor out 2, we're going to be left with what? X squared plus 4x minus 5. Okay. So then completing the square, what we want to do is say we want to add 0 in the form of b over plus or minus b over 2 squared, right? So we're going to do the following. We're going to say plus b over 2 squared, and we're also going to say minus b over 2 squared. Okay. So we're gonna insert that right here. Okay. So then we get this 2. We have our x squared plus 4x comes down. And again, this is just a demo on completing the square. Now our b in this case is 4. So we're going to say plus 4 over 2 squared and minus 4 over 2 squared. Okay. And then the minus 5 comes down. Okay. So then what I want to do, let's go ahead and rewrite this. So this is 2 times x squared plus 4x. 4 divided by 2 is 2, but 2 squared is 4. So really what we're doing is saying plus 4 minus 4 and then minus 5. Okay. So now what we want to do is group the first 3 terms together. So I'm going to separate them with this vertical green bar here. Okay. If we factor the first 3 terms, they factor into, I think it's what, x plus 2 squared. And then minus 4 minus 5 is minus 9. Okay. And then last thing that we like to do is distribute this 2. It takes a little bit of practice to get that correct. But then ultimately you should get 2 times x plus 2 squared minus 18. Okay. And this is our f of x. So that's the original function in standard form. All right. Notice that when x is 0, the corresponding y is negative 10. When x is 0, that's going to be a 2 squared is 4 times 2 is 8. 8 minus 18 is negative 10, right? Okay. So then in this form, this gives us a lot of information about our graph. The coordinates of our vertex are h comma k. That's going to be what? Negative 2, negative 18. Okay. Our leading coefficient, or a, is going to be a positive 2. So that means our graph opens upward, and our axis of symmetry is going to be x equals negative 2. Okay. So we can put all this together. Again, our vertex is negative 2, negative 18. So that puts us in quadrant 3, and it opens upward. Okay. So I'm just going to do some graph paper again. I definitely hit space. Maybe I didn't. Paper. Okay, so I think we're focused on quadrant 3. Can I paste? Nice, okay. Start with black. Okay, so if we're focused on quadrant 3, I'm going to put my origin about here. Maybe a little bit up. Okay. So then our positive x is going to go in this direction. Let's try it again. Our positive y is going to go in this direction. This is our positive x. This is our positive y. Let me see. Our vertex was negative 2, negative 18. Okay. So on the y-axis, I know I want to go by 2s. I'm going to say 2, 4, 6, 8, 10, 12, 14, 16. Oh, I gotta move it up. I probably could have gone by 3s and got it to fit, but this is fine. Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, I think we said it opens upward. And then on the x-axis, -2. Okay. I think I'm gonna go, I'm thinking that'd be my -1. That's my -2. I think that's 3, 4. Okay. So here's my origin. Okay. All right. So again, this went 2, 4, 6, 8, 10, 12, 14, 16, 18. These guys are all negative. This one goes, my 1 is here. No, that's not right. My 1 is here. 2, 3, 4. These are negative. Okay. 1. This one's 2. Okay. Okay. All right. Let's paste. Let me change this. I like this. Okay. So our vertex was -2, -18, put us here. Okay. Let me see, we have a vertex. Let's see when x is 0. When x is 0, the corresponding y, we got our axis of symmetry. Let's actually go ahead and draw that. Our axis of symmetry. Style, we want dashed about that thick. Let's make it a little bit thinner. Okay. Just to help our point to pop. Okay. When x is 0, y is what? -10. So if I paste right here. So notice when we go 2 to the right, we were at -10. So then when we go 2 to the left, we should be at -10. So then we'll just paste right along here, right there. Okay. I feel like, let me see. If we could find our y-intercept, that would be nice. Sorry, our x-intercepts. To find the x-intercept, we would have to set y to 0. I'm kind of out of space. If we set y to 0, I'm going to use my standard form. So if I add my 18 to both sides, divide by 2 makes it a 9. When I take the square root, that makes it ±3. So then our x is going to be -2 ±3. So our x-intercepts, -2 ±3, right? Paste. So -2 minus 3, -5. Man, I made it too big. It's going off the chart. Let me see. It goes what? I can extend it. All right, so it's just a little bit further. Oh. And let's put a tick mark. So if that's -4, -5 is right there. Okay. So we said -2 minus 3 put us at -5. Let me just cut and paste. Okay. And then -2 plus 3 puts us at 1. Paste. Right. I just didn't write that out. If I need to write it out, just let me know. Right. Okay. And then we're going to connect all these with the smooth curve. And again, the reason ours looks a little distorted is just because of the window that I chose. I'm kind of like zoomed in a little bit weird way. But if I match our window with their window, we'll get the same image. And we could also confirm these in our, let me try something. That right hand side keeps getting me. Let me see. If I go the other direction, will it turn out better? A little bit. That's fine. Okay, all right. This vertex is what? -2, -18? This axis of symmetry was x equals -2, and then we had all these ordered pairs. This was the ordered pair 1, 0. This was -5, 0. This one was -4, -10. And this one was 0, -10. So we use the axis of symmetry, the x-intercept, the y-intercept, and the vertex, and connected them all with the smooth curve as we could do. Oh man, we got less than 10 minutes remaining. Party's almost over. What a bummer, right? It might even be less than that. Let's see. Oh, so with this example, we kind of showcased rewriting our function using completing the square to write it in standard form. Another technique that we could have done is use the vertex formula, where the vertex formula will take us straight to the coordinates of the vertex, right? So the vertex formula is as follows. Let's just use this color. So H being the x coordinate of our vertex, that formula is going to be -b/2a. That gives us the x coordinate of our vertex. And then if we want the y coordinate of our vertex, which is our k, we're going to say f of h. So whatever answer we get, we're going to pass it through the function. Then once we have the coordinates of the vertex, that's also going to give us our axis of symmetry. Then we can find our x and y intercepts and use the axis of symmetry to generate a few points on either side and then connect them with the smooth curve, right? So that's the vertex formula. And here, again, let me label it. This is a demo on completing the square. I'm just going to draw a square box. Hey, Google, spell completing.
Completing is spelled COMPLETING.
Yeah. Ooh, she sounds weird. So I don't like English, right? Complete. It ends in an E. It's like I'm trying to think of words that end in that silent E, but when you start abbreviating or augmenting it, you keep the E. Anyway, we got it right, so I'm not gonna worry about it. Let me see. So I think they use so they identify the A, B, and C, and they use the vertex formula, right? Let me see. So since the A was positive, since A was 2, which is positive, that means the parabola opened upward. And in item number 3, they use the vertex formula, H equals -b/2a. Let me make sure I put my negative. -b/2a. Okay. So then that gives us the x coordinate of the vertex. Once we have the x coordinate of the vertex, you can pass it through the function again to find your y coordinate of the vertex. They got the same vertex that we got, -2, -18. And then I think they found the intercepts. Now, when I'm finding my intercepts, I personally like to find my y-intercept first. I feel like the y-intercept oftentimes is easier to find than the x-intercept. The y-intercept, you said x is 0. I think we did it quickly and we got -10. For the x-intercept, a lot of times you have to do a lot more right here. So if they set it to 0, they ended up factor out the 2 and then factor. And I think we did completing the square. I did that just because I wanted to do a demo on completing the square. Now we didn't necessarily need completing the square. I did the completing the square to get it in that certain form, right? But then you have this that you can use to dispose of as well. And then I think they're finding a y-intercept. See how quick and easy the y-intercept is. When you let x be 0, a lot of the terms just cancel out, and then oftentimes you're just left with the constant. Axis of symmetry is the x coordinate of the vertex, and we got the same image. All right, gentlemen. I think I'm going to leave the rest. I'm going to leave the rest as an exercise. I'll say something really quick here. So the domain from a graph, the domain is the very left, to the very right. So for this image, the very left to the very right is going to be all reals. And then the range is the very bottom to the very top. So the very bottom in this case is going to be negative infinity, and the very top is going to be 3 with the square bracket. And then if we want to solve this inequality where our quadratic is positive, that means where is it above the x-axis? So basically between the two x-intercepts. Now they gave us the x-intercepts in this image, so we could just use that. So then our quadratic is above the x-axis between the x-intercepts. So we would say 4 minus the square root of 6 over 2, comma 4 plus the square root of 6 over 2 in open parentheses. Because we don't want to be equal to those, because we don't want to be equal to 0. Because of the inequality. And again, I'm gonna just leave the rest as an exercise. Okay. All right, are there any burning questions before we go our separate ways? Going once, going twice. Okay. All right, gentlemen. So I can't think of any closing announcements other than, what's this? We just started 2.1, so, you should be able to start working on the corresponding homework, and I'll be updating your grades by the end of the week. Like I say, I'm working, whatever grading set I was working on was just taking way longer than anticipated. So, I don't get off until 5 today because I have back-to-back classes. And then after that, I have like other appointments. So, I'll just do the best I can. I'll get it there. I'll get your grades updated as soon as I can. Again, your midterm grade is just based on whatever's been due through exam 2. And basically, those are all the assignments centered around chapter 1, right? That's homework, quizzes, and then 2 exams. And again, it's just a snapshot of where you are in time at that moment in time. It has no bearing on your final grade. Once you see your midterm grade, if it's too low, you're welcome to always go back to your old assignments and redo them. If you made below a 90% on any old assignment, you can always go back and redo them, and the system is going to only register your highest score, right? So if your scores improve, when I go to calculate grades again, it's going to improve your overall grade, okay? Again, if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of the day, gentlemen. Go ahead.
Professor,
Yes.
when you say go back and redo the assignments, do you mean the homework?
Anything that's on Pearson, right? You should be able to access everything on Pearson. That includes homework, quizzes, and exam.
Okay, so, thank you.
Yeah, if you made below a 90% on any assignment and you want to boost your score, I would encourage you to just redo your assignments. Yeah.
Okay.
Any other burning questions? Going once, going twice?
Is like below a 90 bad?
No. It's just getting whatever grade you want, right? The reason I said 90 because there's a 10% late penalty. So like, if you made below a 90, then you can always redo an assignment and it should increase. If you made above a 90, then your score is not going to go up.
Right?
Yeah.
I appreciate it.
Sir, is there any chance I could redo the exam?
Yeah, you should be.
Oh, sorry.
Yeah, you're good. You should just be able to access it. It should be there. Again, if you made below a 90, you just open it up and take it again. You can take it as many times as you want until you get whatever score you want. But I think at this point, there is a 10% late penalty. So the highest you can earn on that would be a 90, which is pretty good for it to be late.
I'm just asking because like on some of my answers, there's just small typos.
Now with that, if you just give me a moment, I can look at it. So maybe you might not have to go back and redo it. Like because I can look at it, and depending on the error, I may or may not give you like credit for it.
But I could go and recheck it.
Yeah, just give me a moment. Let me dismiss the gentleman, and then we can look at it. Are there any other burning questions? Going once, going twice. Okay, gentlemen. So I'll load a copy of whatever you saw me writing in just a moment. And if there aren't any other burning questions, again, we're going to go ahead and end the session here. And from one beautiful mind to another, take care, gentlemen. I'll see you next time on Wednesday, same time, same place. Take care. Peace. Let me